Hey techies and all the data enthusiasts there. So guys, welcome you all to my YouTube channel. It's been long time we came up with a MongoDB video. So if you see, my last video was how you can connect Python with MongoDB, that is using PyMongo, and how you can perform the operations. So that was a great success video. You can say more than 3K views were there and so many likes. I did not expect that particular video to have a great reach. So in today's video, we are going to perform a generative AI concept, which is RAG approach, Retrieval Augmented Generation. So we are going to use RAG approach in this particular video using MongoDB. So there is a MongoDB free version, right? 512 MB database, shared database. So we will be using that and our retrieval augmented generation approach, where we are going to retrieve data from a PDF and store it in MongoDB and build, you can say, QA bot. Wherever you ask the question and it is going to answer the response. So I have the code for that and I'll be explaining you all the RAG approach detailing in this particular video. Now let's not waste our time. Let's dive into my computer screen and discuss more about this particular topic. Before that, if you have not subscribed the channel, do subscribe the channel and on the bell notification to encourage me to make more videos like this. So now let's dive into my computer screen. So guys, I hope you all can see my screen now. So what we are going to do is, let me just open the project folder. So this is my project folder and here is the code for that, QA bot code. So I'm going to explain you all this in detail. So, and we'll be using Jamba research paper for this. So previously I have already created a video on Jamba research paper. So that, based on that particular research paper only, today we are going to build a QA bot. Okay. So I'll remove this here and I'll type CMD. Okay, you will get the command prompt immediately, or you can open command prompt and you have to manually open this folder location. So I directly took this out and I'll type here Jupyter Notebook. So now I'll just run this. So we'll wait for this to execute and open. You can see here, now it has been executed. I can see the screen here. So I guess you all can see my screen here. Let me open this. So first you need to install Llama 2 and other things. Before that, like, let me just enable a markdown and paste an image here. So I hope you all can see this particular image, right, which I have right now. I have opened this particular image. This is called the architecture of RAG. Okay. So let me just give you all a brief overview about this. So here, first, document loader. Let it to be any URLs or a PDF or even you can say this one, a database. From anywhere in these any sources, you are going to get the document. Okay, so this is our document. And whatever document we get, so that is called document loader. And then we are going to split the document into chunks. So it can be different chunks. So based on the sentence, we are going to split it into different chunks. So I'll be showing that in a code, but just understand the architecture for now. So when you see the code, you will get it more detailedly. And after this, so now whatever data we have split into chunks, right? This particular data will be sent to a storage, or you can see it is a vector DB, a vector database. Okay, guys. So vector database, there are many vector databases, right? Like you have Pinecone. So you can search for Pinecone. So this is a official Pinecone website, pinecone.io. So it is a free vector database. You will get here one free vector database. And you have ChromaDB, Fayaz, and many other vector databases are there. Like we can say even there is something called as Quadrant, and even MongoDB can be used now. MongoDB is also a vector database. Now we are going to use MongoDB as our vector database. Okay, I hope you all got this. And after this, what it happens, like whatever split we have made and whatever PDF data we have, right, everything will be stored in a vector database. And once this is done, the retrieval process will be starting, where you will be asking a question, and based on the question, the retrieval splits whatever splits it is there. And before that, we will be giving the prompt also. Okay, we are going to give the prompt, and we are going to like retrieve it with the help of that particular prompt and the cosine similarity method. There are different similarity methods also, like cosine similarity, map reduce. Different methods are there to retrieve the information. We are going to use cosine similarity for now. So using cosine similarity, we are going to retrieve this particular information. Whatever question we ask, based on that, the answer will be retrieved with the help of the LLM model, and it will be provided as a answer. I hope you all got to know about this particular data image, whatever we have. So don't worry, this image which you are seeing, it is just an example, and I'm just explaining you. This is a basic architecture. When you see the complete code, you will get the clear idea. Okay, so we are going to use Llama 2 for this particular video. We'll be using Llama 2 open source library and Langchain framework. Also, we'll be using PyPDF and PyMongo, where we'll be installing all this. Once this is done, now what I'll do is I'll copy the Jamba research paper path. Okay, I'll copy the path of Jamba research paper and I'll paste here. I have even MLOps book. Okay, so that was MLOps book actually, which consists of 477 chunks. So it's taking a bit time, like it is having a bit latency. So to complete this particular video fast, we are just taking a 1 MB file, which is Jamba research paper. You can try out with different books also. You can upload a books, any books. You can try to find out the answer based on this. So let me run this code. I have already installed all this, so I am not going to install them. So once this is done, the next task will be to check the page 1. So once you run this, you can see this is the content of our page 1. It is based on index. Okay, you can give it page 1, page 0. 0th index will be your first page. So I just gave page 1. This is the information of my page 1, whatever information I have. Okay, so now successfully PyPDF loader has extracted the data from our model. Okay, I hope you got it right. From our PDF, from our PDF, the data is extracted successfully. So it is in the text form now. What we are going to do now, we are going to use recursive character text splitter. So recursive character text splitter, you can see here from langchain.text splitter, import recursive character text splitter. So I can directly search here Langchain recursive character text splitter. So you can see here, you got this right. You can open directly the Langchain's official web page. So what this will we do? A text splitter is the recommended one for generic text. It is parallelized by a list of characters. It tries to split on them in order until the chunks are small enough. The default list is /n, /n/n. So all these methods. So this is a default list method. This has the effect of trying to keep all paragraphs together as long as possible. So you can see here, this is the data chunk information what they have given, and this is what internally this recursive character text splitter uses. The separator we can give it like 0 width space or full width comma. These are different regex methods, you can say. So regex and Unicode error methods which we can get. So we can define all this. Okay. For now, you don't need to understand all this. Just see this particular code here. So page 1 is done. So recursive character text splitter, I took this, and chunk size is equals to 1000. So I took it as 1000 letters. Okay, each letter 1, 2, 3, 4 like this will be having 1000 letters as one chunk. Okay, and chunk overlap is equals to 0. What is chunk overlap? For suppose if there is some common names like Jamba. So Jamba might have been repeated multiple times in multiple places in our particular research paper. So if we define the chunk overlap, so it will not consider at that particular point of time. So when you want to retrieve the information correctly, you require to provide chunk overlap as 0 only. So I provided 0 only. You can try out, you can give it 20, 10, you can try out with the chunk overlap. Then what I did, I stored this complete code in a text splitter. Okay, now text is equal to text splitter dot split documents. So this is a inbuilt function available, split documents, and inside this I defined pages. Pages are nothing but whatever data we extracted, right, that we stored in a pages. So this is the pages variable. So this variable I defined here. So now if I run this, it will start to split. You can see here how fast it is. It just took approximately not even 1 second. So fastly it retrieved the information. Okay. Now I'll run this. So this is the text 0 answer. So this is 1,000 letters block. You can see here, this is the first chunk which is of 1,000 letters. Jamba hybrid transformer Mamba language model. So you can see here, this is about it, and meta source data where we got from is Jamba PDF and page 0. It is showing all this. Now let us check the length of this particular text, which is nothing but 53. In a sense, it created 53 chunks. 53 different chunks are there which it extracted from the entire data. Okay. And for this particular approach, right, I'm not going to use Hugging Face. So you might have seen many videos, many of them are using Hugging Face and Hugging Face embeddings. So I'm going to come up with a new approach. So we are going to use Ollama embeddings. Okay. So let me just show you one more thing. Like I took my screen up. So you can see here, here you can see, right? This is Ollama. Okay. It is running. So I guess you all can see this here. So Ollama is officially running in my laptop at the back end. What is Ollama? So for those who all don't know about Ollama, Ollama is you can say it's an open source model, or else you can say application which you can download in your laptop, with the help of which you can download all the open source models and run locally in your laptop. Like see ollama.com, like I'll run this. So in this you have many models here. You have Pi 3 which is recently released, which is 8 hours. This has been released by Microsoft. Okay. Previously Pi 2 was there. This is advanced version of Pi 2. Llama 3 which was released by Meta I guess approximately 4 or 5 days back. And this is the update when they have updated yesterday. Wizard Llama 2, Mixtral, Llama 2, Code Llama, Code Gemma. There are many open source models. You can see if you keep scrolling down, you will be getting all those open source models continuously. So many open source models are there. You can directly download them easily in your laptop and run the code. Okay. So I'm going to use this model only. I have already downloaded Llama 2 in my laptop. So for your confirmation, just I'll open this and I'll select command prompt. Now you can see here Ollama list. You can see here I have Llama 2, Llama 3 and Mixtral in my laptop. Okay. So this, I hope you got this. How to install Ollama and how to install Llama 2 or any other open source models. I have already created a detailed video on it. You all can check out that particular video. Link will be in the iCard section and also in this video description. Okay, you can click on the iCard and view it. Now let us import Ollama embeddings from langchain.community. Import Ollama embeddings, and embeddings is equals to Ollama embeddings. So in an embeddings variable I stored it. So there is something called embeddings here. Like let me just click on integration and embedding model. So here you can see here AI21 Labs embeddings, AWB, Azure OpenAI embeddings, Bedrock embeddings. So BGE on Hugging Face embeddings. So these all are different embeddings which are available. So fast embedding by Quadrant, GigaChat, Firework embeddings, GPT-4 all embeddings, Google Vertex AI Plum embeddings, Gradient Hugging Face embeddings, Jinja and Minimax, Local AI, Mistral embedding. So you can just open this, you can see here. From Langchain underscore Mistral AI, import Mistral embeddings. If you provide the Mistral embeddings open AI API key, you can use it. Okay. So it's very easy. You can use any of these embeddings. So whichever you like, you can use it. Even Spassy is there. SageMaker also it is there, in which you have the SageMaker point of view code, how to embed the data. You can have a look on this. It's very interesting. Okay. So now what we'll be doing. So once this is done, now embeddings are done. Now next task is to import our MongoDB. So to import MongoDB, first we definitely have to create a MongoDB database, right? So it's a quick overview here. Let me just build a database. Okay. So I'll give my database any name. It's cluster 0. I'll give it as vector store. I'll give it vector store. Vector. Okay, vector store. And it is using AWS and Hyderabad region. Let it to be the same. So, and I'm going to use the shared resource. So when it comes to shared resource, you can see here, this is free, right? 512 MB. This is enough for us. So select shared resource. And next, click on Go Advanced. So it's creating new cluster. Once it has created, you can see here, dedicated server. No, we are taking the free server only. So we took this and create the cluster. So once we create the cluster, we get the option for username and password. I already have a default username as Sai and password. I gave it password as 12345. So you can give any password. It doesn't matter. So I already have it. I'm not going to give it. If you want to give it, create your username, any name, and give your password, and immediately you will get here the option to create user. Okay. And here comes the important step. Not my local environment. Make sure you select cloud environment. Okay, when you select the cloud environment, you can access it in cloud. If you select local environment, you should define your IP address here. Okay, remember this. You should define your IP address. So make sure select the cloud environment and give the IP address to whitelist it. Give it 0.0.0, like 4 times zeros /0. You can see here, right, how I gave. You can give it like this and add this. This one is my IP address, simply which I added. It doesn't matter. If you want, you can add your IP address or else you can ignore it. I'll click on finish and close. You can see here, congratulations, the setting up the access rules. Go to database. So now the database is getting created. By the time I'll just click on connect. When you click on connect to vector store, you can see here the drivers option, right? Select the drivers option, Python, let it to be 3.12 or later. I'll copy this, close. I'll go back here and I'll change the URL now. Okay, I'll change this URL which is in the under client. And you all can see here the password. I hope you all can see this password here. So just change this password to the password which you have given. Okay, so I'll give it as 12345. Follow the same step. Okay, and I'll run this. As soon as I run this, you can see here it created something called as a variable client where it stored the URL. Okay, in this I gave again the DB name is equals to Langchain demo and collection name is equals to MLOps. So I should give it Jamba, but it took MLOps. That is fine. That doesn't matter. Okay, or you can change it now also. I'll give it as Jamba research paper, right? So I'll give this, and collection is equals to client DB name and collection name. So this DB name it took and collection name. So collection is here. So now what is your next process is from Langchain underscore community dot vector stores import MongoDB Atlas vector search. So this is the code to import. Okay, so all this code which you are seeing, right, this code is already available in Langchain. You can see here MongoDB Atlas using Langchain. This is the documentation, Langchain documentation. So they used OpenAI, but we are using Llama 2. That's all. We are using. I'm coming up with the open source one mainly. Okay, I want you all to try out. So many of them will not be having their API keys, right? So I came up with open source here. You can see here. So the DB name and client and everything, vector search, everything is defined here. Okay. So now I'll run this. When I run this, it will start to store the data in my MongoDB database. So in this database, it will start to store it. So let's wait for it to start. So it has been started here. You can see here. So now this particular thing is running. Okay. So it is storing, but let me just reload it. So when I reload, I guess you can see. So immediately here you can see here in 11.4b bytes, which is and 197 out. Okay, so now I can just click on this. You can see here it started to work with it. Let me go back. I'll click on browse collections. Okay, So it hasn't created the collections yet. Let us wait for it to create the collections. Okay, so it is taking a bit time. You can see here the data, whatever we have, right? It's getting loaded. So let's wait for it to complete. So it's of 72 seconds now. It will take a bit time. When it comes to the shared resource, right? This is a shared CPU resource. So we cannot expect the MongoDB to be that fast. So let us wait for it to complete this information storage. Then we can see, okay? So let's wait for it. It's going on. Let us wait for it to complete, okay? So I'll pause my video until that. There will be no changes made. Okay, guys. So don't worry. I'm just pausing it to save the time. Let that this particular whatever embeddings it is running, right? Let that data to be saved, and immediately I'll resume the video and continue further. Okay. So guys, it has been loaded successfully. You can see here it took 23 seconds, but there is a small change in the code. Okay. So guys, you can see here. Previously here we were having Ollama embeddings, okay. I don't know why, but whenever I'm running Ollama embeddings, previously it was working good, but now it was crashing. So I changed the embeddings. I took fast embeddings, okay. You can just open this here. So this is the one fast embedded by quadrant. So this embeddings I took, okay. So I told you, right, there are many embeddings. You can choose any one. So I took fast embeddings. With fast embeddings, it was working great. So I have even you can see here like this is the project, right? Let it to open. So here you can see here if I just click on browse collections, you can see here. So the local data size is 301.93 KB, storage size is this much, and index size, and you can see the document size also. Total document size is 53, that is 53 chunks we made, right? So it is 53 different docs. So you can see all the data here, everything is stored. So these all are the data. Okay, so page 5, 4, everything it is stored according to the pages. So what is our next target after this? So after this, what we are going to do? So once we are done with this and once we have got the embeddings, right? So the next target will be to retrieve the information. For retrieving the information, right, there is something which we need to do. Like let me open. MongoDB Atlas Langchain. I'll open this doc. So according to this doc, if you see here, so we need to create a vector search index. Okay. So vector search index, we have to go to our MongoDB's database. So this particular database you all can see here, right? Here what we have to do. So there here you can see something called as Atlas search. Okay. So when you click on browse collections, you will get all this, right? Click on this Atlas search. And in this Atlas search, we are going to create a search index. Okay. Create a search index and JSON editor. Next. So it is going to give you this. So here we have to change the code. Okay. So for this, let me go back here. I'll copy this. So copy this, whatever here it is there. So it is a cosine similarity and it's a vector database and path is embeddings. Okay. I'll copy all this. So everything it came, but the dimension. So each embeddings will be having their different dimension. So for quadrant, what is the dimension for this particular quadrant? We need to see of tokens. Now the behavior is like 512, so they are telling it is default 512 for this. So let me see for Ollama ones, what was the Ollama embeddings. So for Ollama embeddings, okay, there is no specific dimensions mentioned. Okay, so for fast embedded quadrant, I need to see what are the dimensions, right? Let me just check it out. So for Ollama embeddings, you can see here when I search Ollama embeddings dimension, it is giving 4096. So that is correct only. So when it comes to fast embeddings, like our fast embeddings, what is its? Let me just open the fast embeddings by quadrant. So let us check dimension for this also. So we have to change the dimension according to this. So I can see that it supports actually 384. Okay. So this particular quadrant dimension which we have, right? It's 384 dimensions. I got to know that, but I don't see here anywhere the dimensions of it. Normally they take it by default. Okay. So the dimensions are taken by default, but I don't know what is the issue with this particular one. So you can search that, guys, but normally I guess it's 384 is the embedding size. So let me give it 384 only for now. Okay, I'll change this to 384. If it throws any error, then we can change further. Okay, it will show us what is the expected embeddings at that particular time. So I'll give it 384 and we have to choose the database. So I'll select Jamba collection. Next. And this is the search index, create search index. So now the search index is set. Okay, so search index is set. We can go further for coding. So now that is however done, we'll run this prompt. So the prompt, what this custom prompt says, so consider the following research as yourself as a research paper expert. So based on the information and answer the following questions. Okay, whatever information you get, based on that, answer the following questions. Okay, so I'll run this and we are giving a custom prompt template where context and question as an input variable. So from langchain.prompts, we are importing the prompt template and we are running this. Now we will be using Llama 2, I told, right? So I have already installed Llama 2 as I showed you all. So now I'll run this. So Llama 2 is loaded in the variable called LLM. Now I'll run this. So now this will start to retrieve, but it gave us an error. What it says, query is equals to query not defined. Okay. So query we can give it as what is throughput analysis. Okay, so there is something called throughput analysis in research paper, okay, which tells us about the Jamba's analysis research report. So I'll run this. Now it will retrieve the answer, okay. So let us wait for it to run. So query, we are getting it here now. So it's trying to retrieve the information right now. So while retrieving, it might take some time. So let's wait for it to complete. So this video was a detailed explanation about RAG. So I know many of them might have felt what is this retrieval QA and what is this prompt template? What is actually the Ollama? So about Ollama, I already created many videos. There is a playlist for Ollama. So you can check out that introduction, installation, and how you can run Ollama on Docker. Everything I have created a videos. So what these fast embeddings are, what are embeddings? Many of them might have this confusion. So I'm coming up with the Langchain playlist, or even you can say it's a Llama index, whatever it is, like it's a framework. So I'll be coming up with Langchain playlist. So those who all are feeling okay, you want to learn more about this particular topics. So you all can comment below. I'll definitely come up with the playlist very soon. So I'm preparing the content for that. Okay, very soon it will be available to you all. So let me wait for it to retrieve the information soon. It's working right now. So the retrieving is completed. So it took approximately 200 seconds. So that is 3 minutes. It's a free version, right? So it is taking a bit time, and locally we are having the load in our laptop, right? We are loading the Llama 2 model, and it because of that load it is taking. You can see here, throughput analysis is a method used to evaluate the performance of computer system or network by measuring the capacity to handle a certain amount of workload specifically. So it is about this, right? So let us ask any other question also. Let me go to the home session and let me open the Jamba research paper. We'll come up with any new question now very soon, okay? I know the video is a bit long, but MongoDB we need to understand, then we have to definitely see it. So let me copy this Jamba implementation on a single let me copy this both here. So once you run this, then you only need this one, query and qa.invoke to retrieve the information. So I'll copy this. I'll go back. So I'll paste this here. Now query is equals to invoke. Yeah, let us run this. So was it there any space? Oh, I guess it will come up with the answer. It's fine. Let us wait. So I forgot the space to give here. That's fine. It will come up with the answer, I feel. Definitely it can retrieve the information. Let us wait for it. There is load in my laptop, so let me just check what I can close for now. So let me exit Brave. Taking time to retrieve the information, but okay. So now you can see it got executed. It totally took 116 seconds. So let us just copy this, paste it here, and run this. You can see here, based on the provided research paper, the implementation Jamba on a single not mentioned. They provided information about the memory requirements and which is the list of 80 GB. Therefore, the answer for the question. Okay, so it is telling it is not provided as the context, but there is some issue with this. Definitely, we can improve it. So you can see here the output it is coming. So it should provide us according to this. I guess there was some technical issue in this code, but you can try this prompt tuning. So come up with a new prompt, give it a prompt and try again with a rerun it. So then the model will definitely work. So I hope now you understood what is RAG actually. The main objective of this particular video was to explain you all about RAG and how you can perform it with MongoDB, then achieving the greater results. So it gave us some results properly only. So when it comes to here, it takes more time for retrieval. So maybe because of that, and the spacing issue was there. It's fine. You all can give a try. The code link will be in this video description. So you can access it and you can run it. Okay. So guys, that's all for today's video. Do like, share and subscribe the channel. Meet you all in my next video. Bye bye.